Hello all. In this video, let me tell you about the properties of cross correlation. So, Rxy of k is a real valued function. It means the cross correlation always yields a real valued function and it does not give any imaginary functions. Then the second property is the reflection property. Rxy of minus k will be equal to Ryx of k, and we shall prove that in a calculation method. Then this is the third property where Rxy of k square will be less than of Rxx of 0 and Ryy of 0. This is the energy property. Then the fourth property is that when Rxy of k is equal to 0, then sure that the x of n and y of n are said to be uncorrelated and the signals are orthogonal to each other. Then the fifth property goes like this: Rxy of k, that is the cross correlation of x and y, may not be necessarily have maximum value at the center, that is at k equals to 0, and may not be even 2. So let us go through the calculation of a cross correlation. So here the two input sequence I have taken is the x of n and y of n, that is the 1 1 1 and 1 2 3 4. As the samples are 4, n forms 4. Then the formula for Rxy of k, that is the cross correlation, goes like this: summation n ranging from 0 to n minus 1, x of n, y of n minus k, where k ranges from 0, plus or minus 1, plus or minus 2 to plus or minus n minus 1. Note this point. So upon substituting values for n, we will get x of 0, y of minus k, plus x of 1, y of 1 minus k, plus x of 2, y of 2 minus k, plus x of 3, y of 3 minus k. So upon substituting k 0, Rxy of 0, we will get it as 10. And similarly, after substituting for k equals 1, k equals 2, k equals 3, and again k equals minus 1, k equals minus 2, k equals minus 3, we will get the Rxy sequence as 4, 7, 9, 10, 6, 3, 1. This value is the center value, that is the zeroth value, and this is for minus 1, minus 2, minus 3, and this is plus 1, plus 2, plus 3. So this is the cross correlation of x and y. So let's see the cross correlation of y and x here. The formula goes like this: summation n ranging from 0 to n minus 1, y of n into x of n minus k. The same procedure goes like this, but here we are cross correlating between y and x. So the Ryx of 0 will be 10, then the Ryx of k will be 9, Ryx of k substituting 2 will be 7, then for k will be 3, and then the Ryx of 3 will be 4. Then when k is equals to minus 1, it will be 6. So similarly, this is the sequence we are obtaining for the cross correlation of y and x, that is 1 3 6 10 9 7 4. So I have tabulated the Rxy of k also here. So here we can see we are getting the same numbers, but they are cross related. See, the center one remains same, but this here in this plus 1 it is 9, here in this minus 1 it is 9. See, here it is cross related. So this cross relation we have earlier solved in the video where the figure window displays the cross correlation of a x and y signals. So the second property is that the reflection property. So the second property is the reflection property, that is Rxy of minus k will be equal to Ryx of k. So let's do it. As I have earlier tabulated the Rxy and Ryx, so upon substituting the k values, Rxy of 0 will be remaining the same 10. Then Rxy of minus 1 will be Rxy of 1. So the Rxy of 1 is 6. Similarly, Rxy of minus 2 will be Rxy of 2. here I am substituting the k values. K will be 0, k will be minus 1, k will be minus 2. Then when k equals minus 3, rxy of minus 3 will be equal to rxy of 3. So the rxy of 2 is rxy of 2. This is 0, 1, 2, then 3. Then rxy of 3 will be 1. So then substituting k as plus 1, rxy of 1 will be rxy of minus 1. So rxy of minus 1 is 0, minus 1 is 9. 9. When substituting k equals to rxy of minus 2, rxy of minus 2 will be 0, minus 1, minus 2 is 7. So 7. Then when substituting k equals to 3, rxy of minus of 3, that is rxy of minus 3. So the rxy of minus 3 is 0, minus 1, minus 2, minus 3, that is 4. So 4. So let me tabulate the values of rxy and ryx here. So the obtained rxy of minus k, see, this is the tabulated values of rxy of minus k. So rxy of minus k, let me tabulate the sequence. Rxy of minus k, when minus 3, it's so depending on these k values, let me tabulate the rxy of minus k. So when k will be equal to minus 3, we will be getting 1. Then when k equals to minus 2, 3. Then when k equals minus 1, 6. When k equals 0, 10. Then when k equals to 1, we will be getting 9. And when k equals to 2, 7. K equals to 3, 4. So these are the values tabulated. So the equation is that rxy of minus k should be equal to ryx of k. So then what is ryx of k? The previously tabulated values are 1, 3, 6, 10, 9, 7, 4. So we can see that rxy of minus k is equal to ryx of k. So the reflection property is proved. So next, let us prove the energy property. Energy property states that modulus of rxy of k whole square will be always less than or equal to rxx of k ryy of k. This rxx of k and ryy of k is nothing but the autocorrelations. So generally we are taking the cross correlation or autocorrelation for the center. So rxy of 0, that is k will be 0, square will be always less than rxx of 0 and ryy of 0. So let's prove this, that is LHS is always less than RHS. So considering LHS, see, what is the formula for autocorrelation? That is summation ranging from 0 to n minus 1 x of n minus k. Here we are doing the autocorrelation, that is for the sequence x of n taken earlier 1, 1, 1 and 1. So substituting the values of n, x of 0, x of minus k plus x of 1, x of 1 minus k plus x of 2 minus k plus x of 3 minus k. The same procedure goes like we did for the cross correlation. Upon substituting, as we want only the value for k equals to 0, as we are only required with the rxx of 0 and ryy of 0, let's only tabulate for the k value equals to 0 here. Upon substituting k equals to 0, rxx of 0 will be x of 0 plus x of 1 x of n plus x of 2 plus x of 3 x of 3. Substituting the values of x of 0, x of 1 and x of 2 and x of 3, we will get the Rx of 0 as a 4. Then similarly the autocorrelation for y sample, that is y of n will be equal to 1, 2, 3, 4. Substituting n ranging from 0 to 3, y of n x of y of n minus k, that is y of 0 into y of minus k plus y of 1 minus k plus y of 2 minus k plus y of 3 minus k. So substituting k value 0, we will get y of 0 plus y of 1 y of n, y of 2 plus y of 3 we will be getting the value of 30. So then here the LHS is nothing but the Rxy of 0 whole square. So as I have earlier tabulated the Rxy of 0, Rxy of 0 is nothing but 10. From that relation we are getting Rxy of 0 will be equal to 10. So the LHS will be 10 whole square, that is 100. Keep it aside. So we have to tabulate the RHS now. So RHS is nothing but Rxx of 0 into Ryy of 0. What is the value of Rxx of 0? Rxx of 0 is 4 and Ryy of 0 is 30. So 4 into 30. So 4 into 30 we will be getting 120. So from this let us tabulate the LHS is less than equal to RHS. So LHS is 100 which is less than RHS, that is 120. See, here we have proved the energy property, that is summation of Rxy of k whole square is less than or equal to Rxx of k Ryy of k.